So, whether you think about this as values that change up and down in a point, or if you think about it as a point that is moving. So this is position. You could choose to think about it as values that moves up and down in a point, or you could think about it as a point that moves, changing position. So at one time the point is here. At another time the point is here. And what that means is that if this is 12 0 and this is 12 1, that means at this time point there was a value at 12 0, there was a value at that point, but there was not a value here. So we have the A point and B point. There was a value here and at 12 0, at the B point there was no value. At 12 past there is no value at the A point, but now there is a value at the B point. So we come back to the box thing here, where we observe an event at A and B, and I call this source and target. This is, if you don't have to think about it like this, but I like you to have the two slits experiments in mind all the time when I'm talking about these things. So this is a two slits experiment. This is a source. You have a value at A. You observe something here at that time point, 12:01, and then at 12:01, at 12:01, at 12 o'clock and 12:01. At 12 o'clock, you observe something here. At 12, 1 minute past 12, you observe something here. What you observe is a value, and you observe a value. And I just told you there is two ways to think about this. You could think about it at 12 o'clock. There was a value there. But no value here. And then at 1 minute past 12, there is no longer a value here, but there is a value here. Okay? Or you could think about it as there was a object here at 12 o'clock, and then at 1 minute past 12, that object moved over to here in some way. We don't know how it moved, but it moved. We don't know because we don't have an observation in the middle here. So this, keep the two slits experiment in mind when I'm talking about this. I'm going to leave that then, coming back to the pressure, tension, and force again. So what we can think about point in space is that it is a field where every point is defined. This is a field. Every point in space is defined. In this case, let's say it's 0 everywhere in the field. And then suddenly, in this field, there is a value here. We're not going to say where it comes from, but what we can say is like there is suddenly a pressure there, or a tension, or a force appears here in the field for some reason. Another way to say is like there there is certainly some energy here in the field for some reason. And that thing, that can cause a spike in the field like this. Remember, this thing is a visualization of it's a visualization of the values at that point. So now it just happens to be a high value there in the field. So let's say that this happens at 12 o'clock. So since it happened at a specific time period, it means there was an event there in the field. And then, a little bit later on, over here somewhere, we have a new spike in the field, like this. But now, this is gone. And let's say this is 1 minute past 12. This is the same thing. It's also an event. So we have two events in the field. How do we explain them? Well, we could go back to our old pre-20th century thinking and say that, well, there was a particle here. We came in a room, we saw a particle here at 12, or a ball or whatever. And then at 1 minute past 12, we go in and check the room again. And then we see the ball over here. And then we just assume that the ball has been moving over here. How could we confirm it? Like I said before, in between here, 30 seconds past 12, we can go in and check that. So let's do that. We go in here and check. And then we get the spike again. If you recall from a previous video, this is what I call the A, B, and C observations. And this is the A, B, and C observation. So if you did the A observation, then you get your values like this. If you think about the two slits experiment. So this is A plus B. But if you do, I can't get my hand over here, so I can't write here, so I'm going to write over here. If you do the A plus C plus B observations, then you get values like this. So depending how you do the observation, you get different values. So what's my point with all of this? Well, like I said, you could go in and measure in between here as well. Here. And here, and here, and here, and here. You could go in and measure everywhere you want in this experiment. And what it means is that every time you measure, you get a little spike like this in the field. You get a value over there. And what you can do is, like if you look at that field from above, you could say you have like a trajectory in it. Let's say it goes like this. So you could say that, yeah, that's a particle that moves here. That's one thing you could say. What you then say is that the wave, the spike is moving, Or if we think about this as a wave behavior in the field, that if this is a field, so the field is not flat, the field has a wave like this. And it's a wave that moves up and down. So at one time point the field looks like that, and another time point the field looks like this. So this is, let's say, yeah, whatever time point is. But this is one point in time. This is a little bit later in the time. And what I told you, you could think about this in two ways. You can think about it as values that goes up and down in the field. Or you could think about it as a wave that moves in there. So you can think about that this wave top here has moved over here. So this is a wave here. And that wave has moved. That's two ways to think about it. But the point is, none of these ways to think about it is either right or wrong. But if you think about it as values that goes up and down, then there is nothing moving. It's just values that goes up and down. And that means that if it's values that just goes up and down, this thing here is not the same as this thing here. Because this is just a point in space with a value. And this is another point in space with a value. You see where I'm getting at? If you think about it as a moving wave, then that wave crest here is moving in the field. And you get this situation that this is a crest of the wave that is moving in space. But I want to stress it's still point with values that goes up and down. And when you say it's something that moves in space, what you actually say is you're making an interpretation of what's going on in the field. It's an interpretation that there is something moving. Another interpretation is to say that there was something here, then it's gone, and then there is something here instead. And you can correlate those two events in space with each other. Like I said before, quantum mechanics is about there is events, and quantum mechanics correlates these events in space. And then I want to remind you what was said 1932 in the Copenhagen Conference about quantum mechanics. They said the Copenhagen interpretation of quantum mechanics says is do not interpret the math. If I say that it's a value that goes up and down here, that's an interpretation. If I say it's something, it's some kind of object, it's some kind of wave that moves in the field, that's an interpretation. But what they say is like we can't know that. We don't know what it is. Don't try to interpret it. Well, you can if you want, but it's like a meaningless exercise. But what we can say is there is some kind of pressure, tension, or force, or in other words, energy in the field. There is something there in the field. That's what we can say. And with that, I'm going to end this now.